In this video, I'm going to talk about how to solve acute triangle word problems. The goal is to solve problems using primary trigonometric ratios and the sine and cosine law. Okay, let's look at the first questions. Reads the hot air balloon is 750 meter directly above highway. So this is a balloon. So it's 750 meter above highway. This is highway. When it is looking west, it's west. The left west and the right east, right? The angle of depression to exit 85 is 75 degrees. This is 75 degrees. So it's this exit 85. Exit 83 is located 2 kilometers to the near east of the exit 85. So this 2,000 meter away between exit 85 and exit 83. So the question asks us to find what is the angle of depression to exit 83 when it is looking east. So this is it, right? So it's angle of depression, so looking east. So determine the angle of depression to the nearest degree and from the balloon to exit 83. So I draw a diagram and to model this situation. So this is a balloon, so it is 750 meters above the highway. This is 75 degrees angle of depression, looking west. So this horizontal line parallel to the highway, this line. So these two angles alternative angle, right? So they are equal. So 75 degrees. So this 75 degrees. So in this acute triangle, this is a seat, and this is a seat too. Same thing. So alternative angles between the parallel line. So so I marked this side with X, y represent this side. So in this acute triangle, so this side X, this side Y, we know this side 2,000 meters. So first, we determine the X, use this right triangle. So this angle is 75 degrees, right? So in this right triangle, so we know this angle, we know this height, actually opposite side to this angle, this hypotenuse. So we first determine the X. So let's write down. So in the, okay, so sine 75 degrees equals opposite side, right? 750 over hypotenuse is X. So both sides multiply by X, so it's X times 7 sine 75 degrees equals 750. So both sides divide by sine 75 degrees, so it's left side X left. So it's 750 divided by 75 degrees, and 750 sine 75 degrees is 0.97, so equals 776.46 meters. So we know X. Okay, next we find out Y. So in this acute triangle, we know X, right? We know 2,000 meter, this A side. We don't know this side. We want to find out Y, but we know 75 degrees, right? We know two sides. We know the angle between them. We can use cosine law to determine Y. So yeah, let's do it. So Y square equals S square plus, right, 2,000 meters square, right, and minus 2 times and X, right? X is we already determined 776.46 times 2,000, right? And times cosine 75 degrees, right? So when we don't know, so y squared, but x squared we know, right? So we have to write 776.46 squared and plus this 400,000, right? Minus this one already use calculator to determine already cosine 75 degrees equals 0.26. Those already use the calculator to find out is 803.850.543. So the whole right side use the calculator equals 3,799,039 and .589 point, right? So it's both sides take square root when equals 1949.11. So we don't take negative because the length of side is not cannot be negative, right? So okay, so right now we know why, right? We know why in this right triangle we know hypotenuse, we know opposite to angle theta, so we can use sine ratio to determine y. So okay, so let's write down here. Okay, sine theta we want to find out, right? Because opposite over hypotenuse and equals opposite 750, right? Hypotenuse we already get it, so 1949.11 should be only 1, right? So okay, so that's it's a 1, sorry, it should be 1. Okay, equals, already calculate this one, equals 0.3848. Okay, sine theta equals this one, we take inverse of sine, right? So theta equals inverse of sine 0.3848. Use the calculator, is 22.6 degrees. So this is 22. This angle is 22.6 degrees. So the angle of depression from the blue to the exit 83 is about 23 degrees. So this is 23 degrees. This is 23 degrees. Okay, let's move to next questions. Okay, let's look at the second question. The captain of a boat leave marina and head due west for 25 kilometers. Then the captain adjusts the course of his boat and head 30 degrees east of north for 20 kilometers. How far is the boat from the marina? So I draw a diagram to represent this situation as a marina, and the captain leave the marina, head due west for 25 kilometers here, and here this angle is 30 degrees. Is 30 degrees east of north, right? So this side is 20 kilometers. The question asks us to find out how far is R, right? So the first, let's look at directions. Directions are often stated in terms of north and south on a compass. For example, here, right? N30 degree E means traveling direction 30 degrees east of north. 30 degrees east for and north. 30 degrees east of north. Okay, this is 30 degrees east of north. N 30 degrees means. And 45 here, S45W. So look at 45 degree west. 45 degree west and of south, right? Of south. So it's, we know, right? It's top is north, right? Bottom south, and left west, and right east. So okay. So for these questions, so question asks us to find out R. So we know in this triangle, right? We know this side, we know this side, we know the angle between two sides. So in order to determine R, we use the cosine law, right? So okay, let's do it. So we write cosine law, so you know R square. So it's R square equals, and I marked this side length as X, this side is Q, right? Lowercase letter. So R square equals, and S square plus Q square, and minus 2 times S times Q and times cosine R, right? Okay, so we substitute the values. So this R. Okay, so S is 20 kilometers. We use unit kilometers square plus Q square, right? This Q square. Q square is 25 kilometers square, right? Minus 2 times S. S is 20. Q is 25. 25 times cosine 60. And this whole things I use calculator, already get it. So that's 525. Okay, so both sides take square root, so R equals positive negative 20.9. So we take positive value 22.9 kilometers. So the boat is about 23 kilometers from the marina. So this boat is here, so R equals 22.9 kilometers, around 23 kilometers. Okay, let's move to next question. Okay, let's look at the third questions. A weather balloon. This weather balloon is directly between two tracking stations. These are two tracking stations, tracking station A and tracking station B. The angle of elevation from the two tracking stations are 55 degrees and 68 degrees. This is 55 degrees, this is 68 degrees. If the tracking stations are 20 kilometers apart, so it means AB equals 28 kilometers, determine the altitude of the weather balloon. So it means ask us to find out H. This is height. It's altitude of weather balloon. So, okay. So, this is acute triangle. So we know AB 20 kilometers. We know 55 degrees. This angle, we know this angle. So in this right triangle, we know 55 degrees. We don't know AD, right? We don't know H. We don't know X. So in order to determine H altitude, we should know X, right? Right. So I set AC equals X here. So in this triangle, acute triangle, we know this angle, we know this angle. We can determine this angle, right? Because three angles add up to the 180 degrees. We know this angle after this, and we know this length. We can use sine law to determine X, right? After X determined, we can use primary trigonometric ratio and sine ratio, right? Yeah, we know the 55 degrees. H over X is sine ratio. X we can determine by this acute triangle. Okay, let's do it. So first, and let's write, it's determine the angle ACB. So angle ACB equals 180 degrees minus 55 degrees minus 680 degrees. So equals 57 degrees. Okay, so we know this 57, right? Okay, so this is 57, right? So this is X. So we use sine law. X over sine 68. Right? X over sine equals 20 over sine 57, right? So we use this side with this angle and this side with this angle, right? So both sides multiply sine 68 degrees, so X equals 20 over sine 57 degrees times sine 68 degrees. Okay, 20 over sine 57 equals 0.84 times sine 68 equals 0.93. So we know X around 22.1. Okay, right now we know X, so we can mark down. Okay, so X equals 22.1, 22.1. Okay, we know this side, right? In this right triangle, we know this side hypotenuse, this height, this 55 degrees, so we can use sine ratio, right? Okay, so which means sine 8, sine A, okay, sine A equals h, height, this is opposite side, right? Height over x. X is opposite, right? Okay, so as we already know, so we just substitute 22.1. Okay, both sides multiplied by 22.1, so we also know sine A, right? Sine A equals 55 degrees times 22.1 equals h. So sine 55 equals 0.82 times 20.1 equals h. So this is 18.1 h. So the altitude of weather balloon is about 18.1 degrees. So this h, right? So we use sine ratio in this triangle. It's a right triangle. We can determine h. And before we use the sine law, determine x. Okay, let's look at the summary. If a real-world problem can be modeled using acute triangle, the sine law or cosine law, sometimes along with the primary trigonometric ratio, can be used to determine unknown measurement. Drawing clearly labeled diagram make it easier to select strategy for solving the problem. To decide whether you need to use the sine law or cosine law, consider the information given above the triangle and the measurement to be determined. Okay, let's look at these tables. And this column is information given. So this column is a measure to be determined. This is use sine law or cosine law. So if two sides and angle opposite one of the side is given, so it means this two side known and this angle is already given. So we want to determine the angle, for example, this angle, we use the sine law, right? So because this angle, sine this angle over this length equals this angle over this length. So we use sine law, we know three values, three measurement, we can determine the fourth measurement, right? So look at second one, two angle and side. We know this two angle, this side, or we know this two angle and this side. This is include side, it's not include side. So to find out this side or this side or this side, so we use the sine law, right? Yeah, because we know these two angles in this triangle, we can determine the third angle's value, right? Because the sum of the three angles equals 180 degrees. So we know this angle, we know this side, so we can take any angles to determine this side or this side. Yeah, same thing for this. Okay, third example, two sides and content angles. We know two sides and then these content angles, right? So we want to determine this side. So we use cosine law. So why use cosine law? Because the cosine law said, okay, in order to determine this one, this side square equals this square, we know this value. This plus this square, we know this value, minus 2 times this side, and cosine this angle, right? We know this angle, so we can determine, yeah, this side, the length. Okay, the last one, three side. If we know three side, we determine the angles, we use cosine law. Why? Because, for example, we want to determine this angle, yeah, so we use cosine law. This side square equals this side square plus this side square and minus 2 times this side and multiply by cosine this angle, right? But yeah, so only we don't know the angles, right? So we know rest of them, so we can determine cosine angles and then use inverse of cosine to determine these angles.